air, water and equipment. In this module, you will examine some of the characteristics of the environment where you will be diving, learn about some of the essential equipment you will need, and discover how light behaves beneath the surface of the water. Air and water. The world we live in is a physical, tangible reality. Everything we can see and touch has real consistency. These things are made up of elements that can have mass, volume and form. The basic components of an element are the particles called molecules. These elements make up everything that surrounds us. Depending on their properties, they can be solids, liquids or gases. For example, a rock is a solid and has a well-defined mass, form and volume. Although liquids have mass and volume, they do not have their own form. Liquids take on the form of the container they are in, for example, water in a bottle. On the other hand, gases only have mass. They have neither their own form nor volume, but take on the form or volume of the container they are in. Let's now examine some of the differences between liquids and gases. We'll take two containers and fill one with liquid and one with air. Now, with a plunger, we will try to compress them. We soon discover one of the important differences. Air is compressible, while water is almost incompressible. Both elements are made up of molecules, but air contains fewer molecules. Molecules in the air are far apart, and so it's easy to push them closer together. This difference in the number of molecules gives rise to another propriety known as density. In fact, water is around 800 times denser than air. Fins. This difference in density also brings about some other fundamental characteristics. One of these is weight. Volume being equal, a greater density means greater weight. As well as weight, the greater density of water also produces other effects. Imagine that you are running across a field and then wade into water. As you wade into deeper water, walking becomes more and more difficult until you get to the point that the only way to move forward is by swimming. Why is this? When you run through air, you have to overcome the resistance that this gas opposes to your advancement. In practice, you have to force your way through the molecules of air in your path. In water, the number of molecules that you have to move is decidedly greater. This means that to travel the same distance, the force needed is much greater in water than in air. At a certain point, the easiest way to move through the water is by swimming. In this way, you present a reduced cross-sectional area in respect to when you are in an upright position, and it is therefore easier to push your way through the water molecules. Hard hat divers walked on the seabed, and for centuries this was the way man explored the underwater world. Fins are an essential piece of our diving equipment, and were in fact only invented a few decades ago. Today there are various types of fins on the market, often with various characteristics and different features. Fins are made up of two fundamental parts: the blade, which has the task of moving the water, and the foot pocket, which can be either closed or open. Fins with rigid blades produce a greater forward thrust, but they also require stronger leg muscles, otherwise there is a greater risk getting cramp. Closed or full foot fins are more efficient and for this reason are preferred by free divers. Booties have to be worn with open heel strap fins. These booties have a rigid sole and are also comfortable for walking over even rough terrain. And for this reason scuba divers usually prefer to use this type of fin. Different solutions have been studied to make adjusting, donning and removing heel strap fins easier. You should always use fins that are comfortable for your foot shape, and the foot pocket should be snug on the foot, but not too tight. Light in the water. Let's now take a look at what colours actually are and what happens when light enters water. The Earth is illuminated by a distant source of light, the Sun. Sunlight, which we see as white light, is in reality composed of a superimposition of lights of various colours. We can see these colours in the rainbow, the phenomenon that occurs when sunlight passes through a curtain of drops of water. However, if the sunlight is white, why do we see different coloured objects? When white light encounters an object, some of the light is absorbed and some is reflected. If the object reflects all the colours in the same way, it will appear white. However, if the object absorbs the light of all the colours and reflects only that of one type, we will see the colour that is not absorbed. Underwater, you will discover that the natural light is different from that on the surface. There is less light and the colours of the objects change. In fact, everything tends to assume a green-blue hue. Let's now take a look at how this happens. If the sun is directly overhead, as it is at noon, a lot of light will penetrate beneath the surface of the water, while at other times during the day, some of the light bounces off the surface. This is known as reflection. This phenomenon can be seen particularly at sunrise and sunset. However, some light does penetrate beneath the surface, but the angle changes as it enters the water. This phenomenon is known as refraction. Once the light has penetrated the water, the rays of light undergo other alterations. One of these is known as diffusion, that is caused by the rays of light encountering the particles suspended in the water. Another factor is absorption, and this occurs because of the greater density of water in respect to air. If colours are transformed into green-blue hues in the water, how is it that the underwater photos that we admire in magazines are so brightly coloured? The phenomenon of absorption is not the same for all the colours that make up the light spectrum. The warmer colours, such as red, orange and yellow, are absorbed more quickly, and in fact, the absorption of water is selective. After about 5 to 10 metres, 15 to 33 feet, the only colours that manage to penetrate are the green-blue ones. This is why everything appears green-blue. However, if we take a source of artificial light with us under the water, as underwater photographers do, the real colours miraculously reappear. This is the reason why many divers take a dive light with them even on daytime dives. This is obviously a flashlight, especially designed to work underwater. In this way, you can admire the spectacular colours that the underwater world can offer. The mask. Fine, you now know how to move effortlessly in the water with your fins, but if you attempt to look beneath the surface, you will find that everything looks out of focus. This happens because our eyes are designed to function well in air, not water. Freediving record holders use contact lenses that have been especially designed to correct this problem, but apart from the fact that they are extremely expensive, they are also uncomfortable. The simplest way to see clearly underwater is by recreating the environment in which our eyes work best. This is done by a cushion of air being created between our eyes and the water. Diving masks were designed with this objective in mind. Now that our eyes are in their natural environment of air, we can see normally under the water. A mask usually has 1 or 2 glass lenses, a rigid frame, and a soft face seal. All these features combine together to achieve an optimal compromise between an ample field of vision and a reduced internal air volume. As you will soon learn, a mask with a reduced internal volume can be equalized more easily, but a mask that is too small could limit the field of vision. It is essential for divers that the mask also incorporates the nose, because, as you will learn later, this cushion of air has to be equalized. Older types of masks are not suitable for our purpose, because they don't allow you to pinch your nostrils closed so you can equalize your ears. Masks must be fitted with tempered glass, which, if it breaks, does not produce long, sharp fragments of glass that could obviously be very dangerous. Before buying a mask, it is important to try on several so that you are sure of choosing the model best suited to your facial features. Get someone to help you. Place the mask on your face without fitting the strap and make sure that it fits comfortably on your face. Now breathe in through your nose so that the mask is sucked onto your face. It should now stay in position without falling off. Now fit the strap for safety. The strap should be split in the center so that it fits comfortably over the widest part of your head. Also, make sure that it's possible to adjust the strap easily. To make sure that the system for adjusting the strap is really efficient, you should be able to tighten or loosen the strap using just one hand. Now that you're able to see under the water, you may notice something strange. Everything seems larger and closer than it is in reality. Let's examine this curious concept of real and apparent dimensions. As you will remember, rays of light passing from air into water are deviated, refraction. The same phenomenon also occurs in reverse. Our brain, which is used to interpreting these visual sensations in air, reads the direction of the rays of light as if they were travelling in a straight line, as they would through air. Consequently, our brain interprets the object we are looking at as being larger and closer than it actually is. So this explains the difference between real and apparent dimensions. If the glass of the mask fogs, you will no longer be able to see clearly. To prevent this happening, you should smear toothpaste, hand washing paste, or an especially designed product on the inside of the glass every so often. In addition to this, before every dive you should smear the inside of the mask with a surfactant, such as that found in liquid soap or shampoo, in specially designed anti-fog liquids, or, more simply, in the enzymes in our saliva. Finally, it is important to leave a little water in the mask until just before you put it on. The snorkel. Another precious component of our diving equipment is the snorkel that enables us to breathe on the surface while looking underwater. The snorkel is basically a tube and a mouthpiece, but they come in many different shapes and forms. Snorkels are often flexible so that they adapt better to different facial features without causing the jaw muscles to ache. Sometimes this flexible part consists of a corrugated tube. In this case, make sure that the inside of the corrugated part is smooth so no water is allowed to stagnate inside. It should also have an attachment that fixes it firmly to the mask strap. To empty the snorkel of water on the surface, it is enough to blow into it forcefully and the air will push the water out of the tube. There are also self-draining snorkels on the market with one-way purge valves. This system reduces the force needed to empty the snorkel of water, making it no longer necessary to force the entire column of water to the top of the tube. Snorkels are attached to the left side of the mask because the regulator of your scuba equipment comes from the right. Make sure your snorkel is in the correct position so that you can use it comfortably without tiring your jaw muscles. The tubes of good snorkels are of a suitable length and diameter and have a limited curve. The diameter of the tube should be about 2 centimeters, 3/4 of an inch. If it were smaller, breathing would be difficult, and if it were much larger, emptying it of water would be more complicated. The top part of the tube is usually brightly coloured so that it can be easily seen on the surface. All the equipment must be rinsed in fresh water after each dive, even when it is used in the swimming pool. It should then be left to dry in the shade. Thanks to these simple pieces of equipment, you are now able to begin your journey into this marvellous underwater world. In the next module, you will learn what pressure is, how pressure influences volume, why we need to equalize, and what the consequent physiological implications of this are. Until the next time.